Hey everyone, today is number 19 of the Advent of Cyber from TryHackMe, and before anything else, make sure you click on that subscribe button down below if you enjoyed this walkthrough, and without wasting any more time, let's just go back to the computer and see what today's task is all about. Alright, so today we are going to be talking about industrial control systems, and even before we start, let me just tell you that today's task is going to be dense. It is a medium difficulty task, and we also have this information right here where TryHackMe is telling us that you'll probably need around 60 minutes or 1 hour to finish the room. Now, this isn't because the room is difficult or because the practical challenges are difficult to complete, but we have a lot of key concepts that can be quite dense today, alright? So I'll do my best to explain you the things as best as I can, and yeah, without further ado, let's start with the storyline for today. The snow falls heavily over Wareville and chaos erupts at TBFC headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg, shouts a frustrated warehouse worker, holding up yet another Easter themed package. We're supposed to be shipping Christmas presents. And delivery drones buzz overhead, their mechanical hums sounding almost mocking. Each one returns from its route empty, having successfully delivered its cargo. But the cargo is all wrong. You're called into the command center where screens flicker with delivery statistics. Everything looks normal on the surface, 1,000 presents in stock, 98% success rate, and all systems are operational. But the phones won't stop ringing with confused citizens asking why are they receiving chocolate eggs instead of the toys and gifts they ordered. The logistics manager pulls up a delivery manifest. "Look at this," she says, pointing at the screen. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but completely different items. Then, on one of the monitoring screens, a message flashes for just a second before disappearing. Exploit version 6.66, property of Hopsec Island. Why should Christmas have all the fun? King Malhair. Alright, that doesn't look good. Someone has compromised the drone fleet's control system. The attack is sophisticated, falsifying sensor data, manipulating inventory selection, and erasing all traces. This isn't just a prank, it's a calculated assault on Christmas itself. Your mission is clear. Investigate the TBFC drone delivery system, uncover how King Malhair's exploit team has compromised it, and restore Christmas deliveries before Sockmas is ruined. But be warned, King Malhair doesn't leave systems undefended. Traps are waiting for the careless investigator. One wrong move and you might make things much worse. Oh my god, let's hope we don't do that. Now, apparently we also have a mysterious discovery. As you walk through the warehouse control room, something catches your eye. A crumpled piece of paper on the floor near the PLC terminal. It looks like someone dropped it in a hurry. You pick it up and unfold it. The handwriting is hurried, almost frantic. And here is the mysterious note that we found on the floor. Alright, I'm going to copy this because this will be useful down the line. So let me just copy it. But what can we see here? We can see TBFC drone control register map, which is for maintenance only. And then there's a bunch of information about registers right here. You can also see a bunch of information about coils. Okay, really interesting. And then there's also a critical reminder here. Never change HR0 while C11 equals true, because it will trigger a countdown. Oh my god. And this was a note from today, December 19. Alright, interesting. Now, you stare at the note, confusion washing over you. Register map, coils, what is all of this? Exactly, my exact reaction. The terminology is foreign. HR0, C11, Modbus, scribbled in the margin, but something about it feels important, like a key you don't yet know how to use. You pocket the note carefully. I'll figure it out what this means later. Let's do that. So I've copied the note. We will paste it somewhere else where we need it. And yeah, should be good to go. Little do you know, this crumpled note will be exactly what saves Christmas. Awesome. Now let's check the learning objectives for today. And remember when I told you that today's task is going to be quite dense? Well, take a look at these learning objectives. We are going to learn about SCADA, which stands for Supervisory Control and Data Acquisition. We're going to learn about PLCs, which are Programmable Logic Controllers. We are going to learn about Modbus Protocol. We are going to learn how to identify compromised system configurations in industrial systems. Going to learn about techniques for safely remediating compromised control systems, and also understand protection mechanisms and trap logics in these industrial control system environments. Cool. Now, the next step is going to be to set up our environment. And as always, this is going to be pretty simple. Just come here and click on this Start Attack box button and things will start loading, and also click on the green button that says start machine to start our target VM. Now, as you know, I'm a full screen guy, so I'm just going to go at the bottom of the screen and click on the view in full screen button. This will open a new tab on the right, so we will have our attack box in full screen. Come back and click on this minus sign so you can exit split screen view, and then we should be good to go. So now for this question, the clock is ticking, investigator, Christmas is hanging by a thread, and only you can pull it back from the brink. All right, perfect. Let's click check in there. So let's just go to our task number 2 while we wait for our attack box and target VM to deploy. Well, SCADA or SCADA, I don't know how you prefer to pronounce it, basically stands for Supervisory Control and Data Acquisition. And you can think about this as some sort of the brain and eyes of a factory, or as it says here, a nervous system of a factory, because its main purpose is to sense what is happening, to process that information, and then send commands to make things happen. And for today's task, it's interesting because TBFC is using SCADA systems to oversee its entire drone delivery operation. And without it, operators would have no way to monitor hundreds of drones, manage inventory, or ensure packages reach the right destinations. It's the invisible orchestrator of Christmas logistics. Cool. Now, what are the main components of a SCADA system? Well, you can read all about it right here. There's a very nice text that explains you what these components are all about, but let me give you a simplified version of all of this. So let's start with the sensors and actuators. When it comes to the sensors, these are basically the system's senses and muscles, because they are responsible for checking things like weight and position of a certain component, right? And then you have the actuators. These are the ones that are responsible for the actions like moving arms to load packages and so on. So that is that. Then we have the PLCs, programmable logic controllers. Well, these are basically the decision makers, which we will cover in our practical session. Then we have monitoring systems, and these are pretty self-explanatory, right? So we have visual interfaces like CCTV cameras, dashboards, and alarm panels where operators observe physical processes. And then we have historians. Think about this as log databases. They basically store operational data for later analysis. So everything that happens is logged, so then you can then check back and see what happened if something goes wrong. Cool. Now, SCADA in the drone delivery system. Now, there's a couple things that we need to check here in order to understand what we are going to be doing today in a practical session. So apparently, TBFC's compromised SCADA systems manages several critical functions. Okay, so we have package type selection. Apparently, we have different types of packages. We have Christmas gifts, we have chocolate eggs, and we have Easter baskets. Okay, cool. Then we have delivery zone routing. So there are multiple zones for deliveries. We have zones between 1 and 9, which are basically different districts of Wareville. And then we have zone 10, which is reserved for disposal, the ocean. It's a failsafe for damaged goods, but also a perfect target for sabotage. Okay, I'm pretty sure we don't want to send any presents to the ocean, because then a lot of people will be sad. And we are also polluting the ocean. That's not good. Then we have visual monitoring. So this is basically the CCTV camera feed. We have inventory verification. So before sending a package or a present, in this case, we want to make sure that we have that present in stock, for example. And then we have system protection mechanisms, which are basically security features designed to prevent unauthorized changes. Unfortunately, pay attention to this. King Malheur has weaponized these very protections as part of his trap. Okay, we have to keep this in mind for the future. Now, audit logging is also very important. So every configuration change, every operator login, and every system modification should be recorded. Remember here some of the components of a SCADA system. In order to feed these historians, these log databases, we have to make sure that we are logging every single change, every single login, and every single modification to make sure that we can go back and see what happened. But also keep in mind that attackers can turn off logging to cover their tracks. And that's precisely what happened here. And that's not good. All right, why SCADA systems are targeted. This is an interesting one. You can read a lot about all of the weaknesses and the things that make SCADA something that gets targeted very often, but just take a look at all the text in bold here. We have legacy software, we have default credentials, we have reliability, but not security being prioritized. We have physical processes, and so unlike attacking a website or stealing data, compromising SCADA systems has real-world consequences. So there's high stakes whenever something goes bad in some of these systems. And then they're often connected to corporate networks, which might lead to some lateral movement. And also they use protocols like Modbus. And there's a lot of security features missing whenever we talk about Modbus, all right? Authentication is one of them, but we will touch upon this in just a brief second. In the early 2024, the first ICS OT malware, Frosty Goop, was discovered. The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes to device registers over TCP on port 502. Cool. King Malware has weaponized these same tactics, not to cause blackouts, but to sabotage Christmas deliveries by directly manipulating the control system through the Modbus protocol. In the next test, we will explore the PLC, the component he's actually compromised. And now we have a question here. What port is commonly used by Modbus TCP? And we have the answer right here. It's port 502. So let me just type that in there, press enter. Boom, there we go. We got that right. Let's go into the task number 3. And we will start with what is a PLC. Basically, a PLC, or a programmable logic controller, is a tank of a computer, right? It's basically an industrial computer designed to control machinery and processes in real-world environments. These PLCs are running 24/7 for years. All right. They execute control logic in real time, so they are responding to sensor inputs within milliseconds. And these computers, or these machines, are interfacing directly with physical hardware. So they connect directly to sensors. They are measuring temperature, pressure, position, weight, and actuators. So motors, valves, switches, robotic arms. So they will speak the electrical language of industrial machinery. And all of this has to be achieved under extreme temperatures, constant vibration, dust, moisture, and electromagnetic interference. So that's why I told you that a PLC is basically a tank of a computer. But yeah, what is the vehicle that is being used to create this communication between the PLC and all the sensors and the actuators? All right, we have to go into that because that's where we are going to introduce Modbus, the protocol that we are going to use today. And as you can see here, this protocol was created in 1979, and it's one of the oldest and most widely deployed industrial protocols in the world. Its longevity isn't due to sophisticated features, it's actually quite the opposite. Modbus succeeded because it's simple, reliable, and works with almost any device. Now, there is a problem here. This simplicity actually will make Modbus easy to implement and debug, which is amazing, but it also means that security was never a priority here. There is no authentication, no encryption, no authorization checking, and anyone can pretty much reach the Modbus port and can read or write any value. So it's basically the equivalent of leaving your house unlocked and inviting everyone and saying, hey, everything is up for grabs. So yeah, not ideal. And there are different data types within Modbus, all right? We have coils, we have registers. So what is this all about? Remember the note that we saw on the storyline? There was a lot of information about coils and registers. Let me give you just a little bit of context on what this is all about. So let's start with the coils. Well, the coils is a value that can only be true or false, 0 or 1, or yes or no. So it's binary, right? So is the motor running? Is the valve open, or is the alarm active? Then we have the screen inputs. Now this one is also a binary value, all right? And it's also on or off, but it's something that you can't really revert back to, because if the button was pressed, then it will confirm with a true or a 1. And if the door was closed, the same thing. Was the sensor triggered? And then it's exactly the same thing. Now for registers, then we have two types. We have holding registers, which are basically values that you can read and write. So you can set the temperature set point, you can set a motor speed or select a specific zone, and then you can read those values. But the input registers are the ones that you just read. So those are the ones that will tell you the temperature that is coming out of a thermometer, or the pressure that is coming from a pressure sensor, and so on and so on. So this is very interesting. And in TBFC's drone control system, you'll find holding registers storing configuration values. All right, so we have something for package type selection. We have another register for delivery zone and another one for system signature. Again, we have already checked this. And then we also have the coils, controlling system behavior. So we have a coil for inventory verification. It might be enabled or disabled. Protection mechanism, same thing. Emergency dump protocol, auto logging if it is enabled or disabled. Christmas restoration status flag. Interesting. And then we have self-destruct mechanism, armed and disarmed. Okay, the drones can also self-destruct. That is impressive. Okay, remember that crumpled note you found earlier? Now it makes complete sense. Exactly, we had a lot of different values for register and coils, and those values are probably what the current configurations are for all of these specific settings. Exactly, the maintenance technician was documenting these exact Modbus addresses and their meanings. Perfect. So then we have some information about Modbus addressing. And one thing that is important here is that you can see here critical detail. Modbus addresses start at 0, not at 1. So whenever you see 0, so if you have a register with the number 0, it literally means that it's the first register. All right. And then we have some examples from the TBFC system. We already covered this. That's cool. All right. Modbus TCP versus serial Modbus. And here we have some information on things that we already covered. So you can see that modern industrial systems will use Modbus TCP, which runs on port 502, as we checked before. And this is great because it brings a lot of benefits like remote monitoring, easier integration, business systems. But as we already discussed, that also brings a lot of vulnerabilities. So King Malware exploited exactly that fact. The TBFC drone control systems Modbus TCP port 502 was accessible over the network without any authentication required. He didn't need to break into the facility or tamper with wiring. He simply connected to port 502 and started issuing commands as if he were authorized. Oh no, that is not good. So now we have a security problem. And again, you will see the same information about the fact that there is no authentication for this protocol, no encryption, no authorization, and no integrity checking. So this is not cool because modern security solutions exist. We have VPNs, we have firewalls, Modbus security gateways, but they are add-ons. So they are not native to Modbus. They are not part of the protocol itself. So many industrial facilities haven't implemented these protections either due to cost concerns, compatibility issues with legacy equipment, or simple lack of awareness. So yeah, now we are going to connect the dots. Now that we understand a little bit more about industrial control systems and have an understanding of the key concepts like SCADA, like Modbus, PLC, and so on, we are going to dive into the practical session for today. Now, remember that note that we found, that we copied? Well, the maintenance technician must have discovered what was happening and started documenting the compromised values. And the warning at the bottom, I remember reading something about critical, something like that, but it said that never change HR0 whilst C11 equals true. And this suggests that they figured out the trap mechanism before getting interrupted. So in the next test, we will use Python and the PyModbus library to investigate the system exactly the way King Malware attacked it, by directly reading and writing Modbus values. So it's time to see what it actually changed. We don't need to provide any answer here, but it's time to save Christmas. Let's just click check right here and start the practical challenge. So just click in there and let's go. First, we will start with some reconnaissance. So we are going to see which services are running on our target machine. So we are going to copy this command right here, and the tool that we are using is Nmap, so stands for network mapping, and we can actually click here and see what this tool is all about. So it's basically an open source tool that is used for network discovery and security auditing. And we are going to specify this flag right here, SV, which stands for enumerate versions. And then we will specify the specific port, so port 22 for SSH, port 80 for any websites that might be running on this server, and also port 502 to see if we have the Modbus protocol being utilized. And then we will just going to use our IP for our target machine. So again, let me just copy this again to make sure I've copied it. Let's go to the attack box. So on the other tab, let me close this and open a new terminal. I'm going to put this right here. And actually, while that is going to run, let me click here. I'm going to copy this, Control V, there we go. And I'm going to press enter. And while that is running, let's go back to our storyline right here on the introduction. I want to copy this note right here because this is going to be useful, right? So I'm just going to copy this once again, come back here. And now I'm going to open a tool called Sublime. So you can click on this icon here on the top. And we don't need to update it for now, so that's okay. I'm going to drag it here to the left. Cool. I think this is okay. I'm going to create a new file right here, and I'm going to paste my note. There we go, Control V. And I'm going to save this on my desktop as the note.txt. There we go. So whenever we need to go back and check some of the values from the registers, as you can see here, or the coils, as you can see here as well, we can just come here and do that. All right, perfect. Now let's see if Nmap is going to take a while to run. Let's give it just a second. Boom, there we go. Now let's scroll up and see what we have here. We can compare this with the output that is on TryHackMe, but just to make sure that we have everything here as well. So we have port 22 for SSH, all right, so we can log it into the machine if we need to. We also have port 80, so apparently there is a website running here, probably for some CCTV feed or anything like that. And then we have our port 502. So Modbus is running on this machine. Cool. Let's see what we have next. Let me go back to our task and go to the practical task. All right. And then, okay, we already did this. So initial reconnaissance, we got the same exact output as you can see here, port 22, 80, and 502. We got Modbus on our machine as well. Now we specified these ports to speed up the scan. Exactly. So if you were doing enumeration on a different server to have a full view of what services were running on the machine, you could have used this command right here, which would be much more comprehensive, but it would also take a lot longer to run. So we were straight to the ports that we were interested in. And these are the key findings for us. So yeah. As I was saying, we have port 80 for an HTTP service. So there is a website running here with a CCTV camera feed. And also on port 502 again, there's our Modbus TCP protocol, which is the PLC communication protocol. Nice. So now we should go into the website just to check the CCTV feed. Let's see what we have there. So I will open the browser right here. You can click on the Firefox icon here on the top left. Let's just give it a second. Boom, there we go. Now we just copy our link and we press enter. All right, this is not good. Status compromised. Yeah, this is not good. And we can see a lot of Easter eggs right there. So where are all the presents? We have to do something about this. So let me go back and see what we can do. Yes, so through the security camera, you can see the warehouse floor in real time. Robotic arms are busy at work, blah, blah, blah. But something is wrong. Instead of Christmas presents, exactly, we see a lot of chocolate eggs, a lot of Easter eggs. So Easter themed packaging, delivery drones are loading eggs instead of gifts. Exactly. And we also had the confirmation that the system was compromised. Now, the visual confirmation tells you that the problem is real and active, but the system is not necessarily broken. Everything is still working. The robots are doing what they should do. The deliveries are still being made, but there is something happening here because people are ordering gifts, but they are receiving something completely different. So apparently we have a sign of a logic manipulation attack rather than a system failure. So yeah, we will keep this CCTV feed open in a separate tab. And hopefully if we figured out what is wrong and we fix it, things will update and we will have our feed showing actually everything working as it should. So yeah, now we have Modbus Reconnaissance. We'll need to interrogate the Modbus server directly, and this is where Python and the PyModBus library becomes essential. Now, I have a disclaimer here. If you want to replicate all of the steps that we will do here, you will have an issue, all right? So we will start by installing the library. So let's do that. I'm going to copy this. I'm going to go into the attack box. I'm going to minimize the browser. Going back to my command line, I'm going to type clear just to make things more readable. So you can see it here. And I'm going to paste this command. So you can see it that I have it here. Pip install PyModBus and then the version. I'm going to click enter. And while this is installing, I'm going to go back and give you the disclaimer. If you want to replicate all of the steps that we have here, you will have to execute the same commands or the same scripts, right? But what TryHackMe is doing here is documenting the entire execution, but also explaining you what is happening. So here you will see a lot of Python code, but you also have these indicators here, these greater than characters, these dots, and so on and so on. So if you just copy all of this and try to execute it on the attack box, you will have a lot of syntax errors because these things here on the left are not part of the code. It's just something that the Python interpreter adds. So I have created a Python script block text file, and you can see it right here on top of my screen. And if you use this, and I'll paste this in a link in the description, you will be able to replicate all of the steps from here without having to type all the commands in all the Python scripts by hand. So you can thank me later. And I did this to make it way more efficient for you, but also to save some time here on the walkthrough to make sure that I don't have to type everything by hand myself as well. So yeah. What we can do now is, now that I copied all of that Python code, is we can come here into the Sublime, and if I just click on File and then New File, I'm going to copy this right here. And you can go into View, Syntax, and change it to Python if you want to have things looking a little bit more pretty. So just scroll down and select Python. There we go. And then all of the code snippets that we need will be right here. We can just copy them and paste them into our terminal whenever we are good to go right there. All right. So what's the first step? The first step was to install the Python library that we are going to use, which is this PyModBus. And then when you're done with that, what we will do is we are going to start a Python interpreter, and we are going to try to connect to our PLC. And how are we going to do that? By using this code right here. So if I go back, this is what we are going to do. We are going to import this class, this PyModbus client, from the library that we just installed. And then we are going to use that class, this client right here, in order to connect to our PLC by using a TCP connection, but make sure you change your IP address right here. So here you should copy and paste your target machine IP address. So the port is 502 because it's the same protocol. We are all using the same protocol to connect to it, but your IP will change. So let me just go back, and you can come here and you can see here on the top left active machines information. Just click on that and you will see your target machine IP address right here in the middle. Just copy it, go back, and then replace it. So that's what I'm going to do. Let me just copy that, and there we go. I think we're good to go. And now I'm just going to copy this command right here. And what this will do is this will make the connection. And if the connection succeeds, then it will print it was successful. If not, it will print connection failed. So this is what we are copying. And if you're questioning why are we doing this here instead of just going back to the TryHackMe task and copying the code from there, well, it's basically to save time, but also because of the fact that I already mentioned. If you copy the code from here, you will also be copying all of these characters here on the left, and this will not work. All right. So, but the code is basically exactly the same. So I'm going to copy this to my terminal. Again, I'm going to type clear. I'm going to open our Python 3 interpreter. Click enter. There we go. And now the code that we copy from here, just copy it right here. Control-Shift-V. There we go. Press enter. You'll need to press enter 2 times because Python needs an empty line in order to execute the entire script block. And as you can see, connected to PLC successfully. All right, let's go to the next step. So we have a connection to the PLC's Modbus interface. Notice how no authentication was required. That's quite funny, right? Because we didn't need any credentials. We didn't do any login. We just connected. And now let's start doing some reconnaissance and see what sort of information we can get. What we are going to do now is to query for the reading holder registers. And the first one that we are going to check is the holding register 0. If I go back to my attack box and instead of going here to the code, if I go back to my note, please take a look at this. What is the holding register 0? This is the type of package. Like we now are going to be able to see when we query this, which packet are we actually sending? And maybe this is the reason why we are not sending Christmas gifts, but rather chocolate eggs. So if we get the number 1 when we query for this holding register, it will confirm that this is the reason why we are actually sending the chocolate eggs. So let me go back to my, I don't know why this is untitled. I forgot to save the file. So let me save this as well, just to make sure I don't lose it. And I'll just call this Python script blocks. Okay, cool. Now I have it here. So this is the second block that we need to copy. So we are going to query for the register 0, Control-Shift-V, press enter, enter again, and there we go. We get the number 1. So we are basically sending chocolate eggs to everyone. And that's not what we want. We want to send Christmas presents. But let's keep navigating and query things further down and see what is happening here. But as you can see here on TryHackMe, there it is. HR0 is set to 1, which means the system is configured to load chocolate eggs. So the note was right. This is exactly what's causing the problems. Now let's check for the holding register 1, which is the delivery zone. Hopefully we're not dropping any presents in the ocean. Remember, if I go back to my notes, if we check here for the HR1, it's the delivery zone. If it gives us a number between 1 and 9, everything is fine. But if it is 10, then we have a problem. So let me go back to the Python script. You can see this code that I have here, once again, just to make it clear, is exactly the same one that you have here. So I'm just going to copy it, come back here, Control-Shift-V, enter, enter again, and yes, okay, everything seems to be good, so no worries here. Number 5 is within the range of 1 to 9, so we don't have a problem. Again, as you can see here, everything checks out. Now we are going to check for HR4, which is the system signature. Now let me check the node for that. Do we have any information about the holding register 4? System signature version, the default should be 100. Anything that is different might be indicating that something is wrong. So let me go back to the code. Let's copy this 4th code snippet. Control-C. Let's go back to our terminal. Control-Shift-V. Enter, enter. And yes, you can see our signature here. it says 666. So this is not good. Apparently we have exploit detected, and this is the King malware signature. Let's see what TryHackMe is telling us about this. So the value 666 confirms the system has been compromised by exploit framework. This matches the taunt message we saw earlier. Exactly. So if you go back to our introduction right here, you can see that this was the message that was being shown in the beginning. And again, you can see the version of exploit 666 right here. Oh man, let's go back to the practical and see what else we can find. Now I'm starting to get interested in this. All right, so we already did this part. We checked the system signature right here. And now we are going to start querying for the reading coils as well. And the first one that we are going to check is for the inventory verification. Are we actually checking our inventory before sending a present? So let me go back and copy the code. So it's right here. It's coil number 10. I'm going to copy this, copy it back to my terminal, enter, boom. And apparently it's disabled. System is not checking for the stock before sending anything. This is not good as well. Everything seems to be misconfigured. What is happening? Next, we are going to check for the coil 11, which is the protection and override. Now, if we don't have any protection enabled, I'm gonna start being very, very worried about this. So let me copy the code again. And let me copy it to my terminal. Press enter. And for the coil number 11, it's active. Okay. This is good. At least changes are being monitored. Let's see what TryHackMe tells us about this. This is crucial. Yes, C11 is enabled, which means that the system is actively monitoring for changes. Remember the warning on the note. Never change HR0 while C11 is true. This will trigger a countdown. Can we double check the note to see if this is true? Yes, this was the critical part of the note. Never change this while this is true. Okay, this will trigger a countdown. Let's keep that in mind. Now, let's check coil number 15 for self-destruct status. I hope this is not enabled, right? I hope drones are not just exploding everywhere. So we have the code here, but I have it ready right here just for us. So coil number 15, and this is the last one. So cool. Let me just copy it to my terminal. Enter, enter, and it's false. Okay, not armed yet, and we are saved for now. Perfect. That is cool. Let's go back to TryHackMe and see what we have here. It's good news because this isn't armed yet, but this will be triggered if we try to change HR0 while C11 is active. And this was the trap that the attacker was trying so hard for us to fall, but we are not going to fall for that. Now, this step 5 is crucial for you to understand the trap. Now that the node makes complete sense, we actually can go to the node, check the values on the registers and also on the coils and actually see what is what. Through our reconnaissance, we were able to see that this register was set to 1, which was forcing the Easter eggs instead of the Christmas gifts. C11 protection is enabled, which means that we are monitoring for changes. But if anyone changes HR0 while C11 is true, C15 will get armed and then auto destruct will be enabled, and that is a problem. And once C15 is armed, a 30-second countdown begins, and after 30 seconds, C12 emergency dump activates and everything dumps to zone 10, which is the ocean. And this is not what we want. And then if we check this little note here, we can see that whoever wrote that note was trying to make sure that we, while trying to fix things, would not make things worse. Because if we just went there and changed the first value of the register to 0 instead of 1 to make sure that we were actually delivering the Christmas gifts instead of the Easter eggs, while C11 was enabled, all of this would get triggered and things would get much worse. But now there is something important that I need to tell you. All of the things that we have done so far are very important, but as you've noticed, it's not very agile. It's not very efficient. We are enumerating every single register and coil individually one by one. So we need something that actually gives us all the information that we need with just one execution. And this is where TryHackMe is going to help us, because TryHackMe is going to give us a script that is going to allow us to query all of the registers and coils that we need in order to get all of the current values and then output that information all at once. So I'm going to copy this script right here. This is the complete enumeration scan or reconnaissance scan. Now keep in mind this is a 95-line script, so it would take a lot of time to go line by line to explain you what is happening, but just very short, you can see that here we are declaring our IP address for the target machine. We are also declaring the port 502 to connect to the PLC. And then we are actually doing the enumeration, the reconnaissance on all the registers. So you can see here registers, and then we are declaring them right here. And then we are doing the queries of them individually and also the coils. And then at the end of it, we are going to see the results, and let's see what happens there. So let me go back to our attack machine. I'm going to go into the Sublime and create a new file, and I'm going to paste this script, and I'm going to save it again on the desktop. So save as on the desktop as Recon, as short for Reconnaissance.py. There we go. And now I'm going to exit this terminal right here. So you can just type exit and double brackets and press enter. You're good to go. I'm going to type clear to make everything more readable to you. And now I'm going to type cd to change the directory to my desktop. Press enter, clear once again. And now I'm going to type Python 3 and the name of our script for Reconnaissance, which is recon.py. Press enter, and oh wow, that was very, very fast. And you can see the results of our Reconnaissance script. So we have the values for all of the registers that we queried. So again, we also did this manually one by one. Remember, the value for HR0 was 1, so we are sending eggs, not Christmas gifts. The HR1, remember the zone was 5, so we are good within the normal zones. Also, we check for the signature, for the malware that is being used. And then we also check for some of the coils, but not all of them. I remember we checked for 10, 11, and 15, but we didn't check for all of this. So we can see here that we have one for emergency dump on the C12, which is false. We have C13 for audit logging, which is also false. This should be true so that we could log all of the changes that are happening. This is how the attacker is actually hiding his tracks, not to be detected. And then we also have this C14, Christmas restored equals false. Auto set when system is fixed. So we will probably need this. If we go back to our notes real quick, just to give you a fun fact, can you see here what says on C14, on the coil for C14? It's actually called Christmas restored flag. Just a little FYI. So let's go back, and we can see that the threat assessment is that, yeah, exploit framework was detected, protection mechanism is active, and a trap is set. Package type forced to be eggs, inventory verification disabled, and audit logging is disabled. We need remediation. So how are we going to fix this? Well, TryHackMe also is giving us a script that we can run in order to fix all of this at once. So we could go and fix one by one, but this is not what we want. We want something that automates the process and fix all at once so that we can fix our operations, right? So we can see here for safe remediation, again, to avoid the trap, based on our reconnaissance, we need to disable the protection mechanism first. Remember, we cannot change the HR0 to send Christmas gifts before we disable this protection, because if that happens, everything will get triggered. We will get a countdown. Things will start exploding. We don't want any of that. We don't want to send any presents into the ocean. So let's not do that. So the first thing that we need to do is to disable this protection mechanism. Then, only then, we can change the package type to Christmas gifts. So this would be on the register 0 and change the value to 0. Then we can enable inventory verification once again. We can enable the audit logging, and we will also be able to verify that C15 was not armed. All right, the order is critical. Yes, we already covered that. And here, by the way, TryHackMe is telling you to use Nano. I'm just using Sublime because we were already using Sublime for the Python code. So it's just easier. And if you are not used to edit text on the terminal, it might be a little bit out of your comfort zone for now. So I'm going to keep using Sublime, but feel free to use Nano. It's still a text editor that you can use within the terminal, and it's not very difficult, but I'm going to use this method instead. So just copy this script. Again, this is a very long script, but what we are doing is changing the values from all of those register and coils that we need to change in order to restore our operations to normal. And again, it's a simple script. We are declaring our IP address for the target machine, same port to connect to the PLC, and then we are actually changing the values to the parameters that we want the coils and registers to be at. All right, and then we are also going to check some things at the end. There is something very interesting here. Can you see here? Read the flag from the registers. There is actually a method here that will create the flag if we actually are able to do everything. Now, if Christmas is restored and the new package type is 0 and there wasn't an emergency dump and there wasn't any self-destruction, again, this is being checked just in case someone tries to change the parameter of the first register to Christmas gifts. before deactivating the coil on C11. All right, so if this is successful, then I can already see that we will have success and everything will be restored, and we will be able to check the CCTV and see if everything is good to go. All right, so I've already copied this code, so I'm going to go back to my attack machine. I'm going to create a new file. All right, and I'm going to copy the code right here. I'm going to save it on the desktop, and I'm going to save it as restore Christmas. If I can type, and now I'm going to press enter. There we go. I'm going to go back to the terminal, type clear, just to make things more readable once again. Again, Python 3. Let's call our script restorechristmas.py. Press enter. Let's see. Okay. Everything is executing step by step. This is important. All right. So, okay, let's see. All right. Success. Christmas is saved. You can see that step by step what we did. We were verifying the current system state. Package type equals 1, X, all right, and protection is active. Self-destruction arm is false. So the first thing that we did was disabling the protection mechanism, not the gift, and that was disabled. And after that, the script actually changed the package type to Christmas presents, so that is perfect. And then we enabled the inventory verification, we enabled the audit logging, and we verified the system restoration to realize that everything was a success. Awesome. Let me go back to the browser and, oh, yeah, it says here that the system was restored, and we can see that Malher is not very happy. But yeah, that was it. And we also have our flag right here. So let me just copy it and go back to the main task, scroll all the way down, and you will see the question right here. So just paste it, click on check, and there we go. Now, if you enjoyed today's room, you need to check out this OT challenge called Industrial Intrusion. I think you will love it. So I'm just going to press check on that as well. And we're done for today. That was a lot of fun. And that was it for today. I really hope you enjoyed today's walkthrough. If you did, please remember to hit that subscribe button, leave a comment below, and I'll see you in the next one. Bye!